Now we want to prove these two theorems. This is proving line from a center. So this theorem is line from the center. We all know that line from the center, we can all see that the line from center. So we just want to prove that theorem there, a line from center. Now there's two conditions. Line from center, the first condition is that if you have a line that is from the center that is perpendicular to chord, then it bisects the chord, and the second condition is, now we have a line from center. It's still the line from center, and then this line from center, it bisects the chord. Then the line is perpendicular to the chord. And so those are the two situations that you have. Those are the two situations that you have. You have there. Now you have a line that is drawn from the center. It's perpendicular to the chord, therefore it's going to bisect that chord. Or you have a line that is from the center that is going to bisect that chord. So it's bisecting that chord, making the angle now perpendicular, just making the angle perpendicular. So now we want to prove these two, because they can be asked anyhow in an exam. So now we prove both theorems using congruency. We prove them using congruency. Let us just start with what is it that we are given for the first one. So we are required to prove that RT is equals to TS. This is what we must prove. We are given that O is the center and that OT is perpendicular to RCS, is perpendicular to RTS. Now we want to start with the construction when we are proving. So we're going to construct the radii, which is OR. We're going to construct by joining OR and OS. OR and OS. So I'm going to be having OR constructed, and I'm also going to be having OS constructing both of them. So now, after I've constructed those two, I can now move on with my proof. I've done those two. I'm going to say now in triangle R, in triangle ORT, and triangle ORT and triangle OTS OST. So in both of those triangles there, we are having the fact that OR and OS are equal. OR and OS, they are equal because they are radii, and we have OT, which is common, and we also have angle T1 equals to angle T2. Angle T2, they are equal to 90 degrees, both of them. So angle T1 equals to angle T2 because they are both now equal to 90 degrees. We were told that OT is perpendicular to RTS. So this was given because we were told that it's perpendicular. So and then I say now, therefore, triangle ORT is now congruent. It's now congruent to angle OST, and I'm going to give a resonance because I've proved that the hypotenuse, the radius, and the hypotenuse, which is the radius, the common side, and the right angle. So I've proved that the right angle, which is the 90 degrees, is equal in both triangles. I've proved the hypotenuse, which is the radii, and also proved one side, which is OT, which is common. So and then the last step is now I say therefore RT is indeed equal to TS, and they are corresponding sides of congruent triangles, corresponding sides of congruent triangles. Yes, and so that's how I would prove this first theorem there. That is how I would prove the first one. Just use my congruency. I use RHS. Now the second one, how am I going to prove the second one? Every proof you start with a construction. Without construction, then you know that you are going to lose marks without the construction. So this one, even though M1 is indicated, M2 and M1 are indicated as 90 degrees, that's what we need to prove. So we just ignore this M2 as 90 degrees. We focus on AM and BM because that is what is given in our statements. Then we have to prove that OM is perpendicular to AB. So just like the previous proof, I am going to do the same thing. I'm going to do the same thing, see what is it that I'm required to prove. Must know what it is that I'm required to prove. I'm required to prove that OM, or I can say MQ is equal to 90 degrees. Because that 90 degrees means now they are perpendicular. So I am given that O is the center. So O is center, and I'm also given that AM is equal to MB, and that's what I'm given. So now I start with a construction. I'm going to construct both the radii, the two radii. I'm going to now say construct by joining AO and join AO and OB, and then now I show my construction. Remember, it's important to show the construction. So we are going to join AO and OB. So join AO, and I also join OB. That is now my construction. And then now I can move on to the proof, and I'm going to start and say in the two triangles, which is basically triangle AMB and triangle BMO. So those two particular triangles there, AMB and B, it's actually AMO, sorry for that. AMO is this triangle here, and triangle BMO. So those two particular triangles there. So in both those two triangles, AMO and BMO, I am going to have AO is equal to BO. AO is equals to BO. These are my radii. These are my radii. And then OM is common. OM is common. And AM is equal to MB. It's equal to MB. Remember, this was given in the statement. So this is what I was given in my statement. Those were given. So I can now just complete my proof. Can now complete my proof, and I'm going to have therefore triangle AMO is congruent, or you can use the symbol for congruency. If you don't want to write congruent, use the symbol for congruency. Is congruent to triangle BMO. And then now what I am going to do now is conclude and say therefore M1 plus, I'm supposed to give a reason here because I've proven that the radii, there's a common side and there's two given sides, so that's side, and therefore M1 plus therefore M1 equals to M2. M1 is equals to M2. These are the corresponding angles of congruent triangles. But M1 plus M2, they are equal to 180 degrees because they are on a straight line. Angles on that straight line. Angles on a straight line. Therefore, angle M2 is equal to 90 degrees. So those are the two proofs. They can be asked in an exam. It's basically line from center theorem. And so this line from center theorem, it can be asked in these two different ways. Just put this one here, this side. So it can be asked in these two different ways. It's useful to know both methods, both ways of proving it, in my own opinion. 5 marks for each, but they are fairly simple to remember. Remember now, you can be given that the line from the center is perpendicular to the chord, then it bisects the chord. That's the first one you can prove. So see, in the first one, I was required to prove that RT is equals to TS because now the chord is bisected by the perpendicular line. It's bisected by that line that is coming from the center. So I prove it. Or now I am given that the line from the center has already bisected the chord. I just need to prove the 90 degrees. So this one I use RHS, this one I use SSS, congruency.